Okay, welcome back. And again, I wanted to again reemphasize that what we have coming up is actually very, very remarkable. It has been a journey. I got Gan and Suni down here, who are the account manager and the CSM for PETRONAS, doing a lot of dry runs, 12-hour time shifts, so you can see there's a lot of late night rehearsals. But as I mentioned this morning, this one has a lot of personal tie to me because, you know, again, I was involved in the 2012 to 2015 timeframe. Was part of helping prepare the enterprise agreement, which they are now, and it's really fulfilling to see the maturation and the continuing journey that the PI system and the AVEVA portfolio is playing at PETRONAS in their journey become the leader, if not, they are really there now. But as you'll see, this is a kind of a special program that we put together to essentially set the context of what they're doing through 5 illustrative use cases. And so what you're going to see is an introduction and then 5 10-minute or so vignettes, each of them talking about a particular application. And so I think you will find it's very fascinating, very motivating, and quite impressive. So without further ado, I'm going to go ahead and ask the PETRONAS team to come on the stage. The format is that the majority of them will be obviously sitting down, and we'll do an introduction, and then each of them will be come up and do their little vignette. So please welcome the PETRONAS team.
Hi, hello everyone. Thank you for joining. It's good to be in Amsterdam. Today we will be sharing on the not 1, 2, 3, but 5 use cases in PETRONAS, how we accelerate the synergy value from the expanded AVEVA portfolio. Just to share what we'll be sharing today, first we'll get to know on PETRONAS at a glance. Next, we'll be sharing on the PETRONAS journey of using AVEVA products. On the first use case, we'll be sharing on the Beyond Data, Insight and Wisdom for PETRONAS Gas Business Division Leadership. For use case number 2, we'll be sharing on PETRONAS Gas Processing Unit Technical Center. Use case number 3, we'll be sharing on enabling smooth operation by flowchart automation through PI-AF. Use case number 4, on the earlier failure detection using AVEVA Predictive Analytics. And the last use case we'll be sharing on the enhanced insight by leveraging first principle process simulation. So for those who don't know PETRONAS is a Fortune Global 500 energy company. We have presence in over 50 countries. Recently, we've changed our statement of purpose, where we are currently a progressive energy and solution partner, enriching life for a sustainable future. We have a multiple portfolio ranging from upstream, downstream, gas businesses, and the new division which is covering more on clean energy solution to cover the sustainability aspect. Our journey of using AVEVA products on top of PI and also AVEVA product portfolio, we've started using PI system back in 1991, and we've been expanding our use of PI system throughout 2011 until 2019, where we collect all the operational data across different businesses, as we mentioned just now. And the reason we are proliferate the use of the PI system is to driven the importance of data, not to only to enhance the data so that it can generate more insight and also wisdom as well. Through the expanded use of PI system, we've realized that we need to sign an enterprise agreement with Aussie back then as a strategic movement to unlock the data from the instrument in our sites so that we can generate more insight and wisdom. So some summary of Pi system at PETRONAS. We have more than 100 plus of Pi servers, which covers on the data archive, Pi AF and Pi Vision. We have close to 3.5 million number of tags. That number of tags included the raw tags from the instrument and also the calculated tags coming from the Pi AF analysis or other simulation tools. We've been using Pi AF templates to help to scale our solution at pace. We have close around 200 templates where it helps us to scale up our application much faster, as you guys will be seeing later on by our presentation. And we also leveraging on use of Pi Vision for our visualization, where we have close more than 4,500 Pi Vision page, where we use for multiple purposes. On the AVEVA product portfolio journey and overview, the first use case that we have of using AVEVA Prism or predictive analytics is to use for rotating equipment. Later on, my colleague will be talking more how we generate value by using this predictive analytics for rotating equipment. Not only we've been using it for rotating equipment, we've been experimenting it to be used for static equipment like furnace and boiler as well. Next, in the morning, just now we've presented on our use case of UOC for our enterprise optimization. So we've been using that to provide the enterprise view of molecule movement. And there are a lot of AVEVA products that we've been using to help us to unlock and generate insight and wisdom, like UOC, Prism, Romeo, AIM, Production Accounting, Spiral, and Wonderware. So, are you guys excited for the next use case? I'll be passing the stage to my colleague Fauzi and also Ridwan for them to present use case number 1.
Thank you, Ashman. Hi, good afternoon. I'm Fauzi. Today I will share with you, together with my colleague Ridwan, insight and wisdom for PETRONAS for gas business division leaderships. So basically, gas business division is another division on top of what we have existing upstream and downstream. To give you in a glance, we are coming from Malaysia and then we operate in Malaysia. Malaysia basically stated just below Thailand, above Singapore, and we also shared a big island together with Indonesia. So for gas business division, we consist of LNG and gas business and also the marketing arm to commercialize our LNG and gas. So in Malaysia, we have 5 gas processing and utilities, 2 regas terminal, more than around 3,000 gas transmission pipeline, 9 LNG trains, which is stated in a single location, and then 2 floating LNGs. The floating LNG is one of our proud assets, where the floating LNG is the first floating LNG in the world. To give you some idea how we operate our assets, we have more than 300,000 Pi tags, where all those Pi tags being managed or being visualized through the existing platforms that's available in each respective assets. One of the platforms later will be shared by my colleague Johari on GTC. Besides Malaysia, we also partner with other players for our LNG assets in Australia, Egypt, and also Canada. Today, Go Dashboard is an integral platform for gas business division. If you refer to our presentation earlier this morning, we have an EOC, a platform for PETRONAS leadership, while for Go Dashboard is another platform for us, just specific for gas business division. So this dashboard basically provides a strategic dashboard, giving insights for our day-to-day operations. So basically, it's integrate all gas business division assets and getting all those feeds from the upstream and then provide all those products to our counterpart in either downstream and also the customers. We develop the dashboard through each respective persona that has been identified, and then we focus to the key parameters instead of getting all those 300,000 pie tags. And then also it gives assurance of information by relying the integrity of the data source. So I will pass this presentation to my colleague Ridwan to bring us the journey of Go Dashboard with the hashtag of throwback. But rest assured, I will come back and bring you guys to the dashboard that I will demo it later. Okay.
Okay. Thank you, Fauzi, for the introduction of Go Dashboard. So hello, everyone. My name is Ridwan. I cannot see you very much, but I hope you're there. Okay. So I will actually I will share to you on our journey on Go Dashboard. So, okay. I think throughout the presentation for the past 2 days, we all share the same pain point. Everybody have abundance of data. Everybody have their own asset monitoring platform. So this one has cost us, of course, we are engineers. We have a lot of data. So we analyze the data. So you cannot blame us for analyzing the data because that's our job. But at some point, you're going to have to face analysis paralysis, whereas you are being puzzled with all the analysis, and you start to question each other's numbers. So that's what's happening. You start to question, oh, which one is the correct number, yours or mine? So that's the analysis paralysis that we actually observed in the past. So we do observe also from our leadership team, there are lack of visibility on the scenario from the side to the visibility team, to our leadership team or our C-suite at Gas Business Division. So we turn these challenges into opportunity. So there are 3 parts on these slides. The first part is on the user experience. This is the most important part in any digital solution, the visualization. So as the saying goes, a picture tells 1,000 words. But which words? There are 1,000 words. So that's why we ask back to our stakeholder, what do you want to see? How do you want to see? How do you want to navigate? Do you prefer drop-down? Do you prefer mouse over? So that kind of user experience is different between personas. This is important because we need to ensure that they are actually adopting to that solution. If the first glance they say it's not wow to them, so then they're going to start, the adoption is going to be very low on that part. So after all iterations, so many mock-ups, so many wireframes, so we conclude that actually our persona prefers skeuomorphic design. So skeuomorphic design is actually an image, it's a real world image, and you overlay it with data. So with this UI, we can proceed to the next part, which is number 2 is on the content. So everybody in data practitioners are familiar with the wisdom hierarchy. So where actually want from data how you want to elevate it into wisdom. So I'm going to give you one simple example in our use case, how we actually transform one data to become wisdom. Okay, let me give you one figure, maybe 220 tons per hour. So that is one data. So there is one data, but what does it mean? You cannot make any context from that. So that's why how to turn this one into information, you need to inject some context into it. So we use a simple function of traffic light. So everybody knows traffic light. Red is not good. Green is good. Yellow is in between. Maybe it's good, but not that good. So we use this traffic light to actually indicate how is this figure compared to the KPI. So by giving this context, we elevate this data to become information. Of course, when we have this red 220 tons per hour, of course, the obvious question will be, why is it red? So that's the usual question that we get. So instead of we want to asking people why is it red, we automate this information to become knowledge by actually injecting the meaning to this information. How we do that? We use Microsoft Power Automate. So our shift manager at plants, our offshore installation manager at floating LNG, they can actually put their verbatim in the platform, and using Microsoft Power Automate, this one will be actually being conveyed to the platform to our vice presidents to explain why is it red. So you eliminate the function, the need to actually asking people around why is it red, because that's the always obvious question, why is it red? Because if you screen, nobody will ask question. Okay, so with this information become a knowledge, you know why is it happening, then you try to integrate all these knowledges, you combine it with the UI that they like, you combine it with the persona that they want, so then you can have a wisdom. So the C-suite members can actually see the overall view of the asset performance from one glance, and then they can start to think what can be optimized, what can it, how is it performance on that part. So that's the content on the second part. The third part is, of course, on the team. So on the team itself, we're working in Agile. We have pod members from all over our assets. Why we do that? Because we want the accountability on the data integrity. Because we believe that the data integrity should be at source. So they need to be responsible for data that they generate. Okay? So this is the architecture, how is actually our Go dashboard is being combined and later visualized in our visualization platform. Pi, AVEVA Pi is having a backbone of our ecosystem because we want a near real-time data. This Pi data archive, we have Pi AF to do the calculation and logic, and also we have a Pi integrator to actually send the data to our ETL. So we combine this also to other applications that give another information from our counterparts. We use Microsoft SharePoint to give the manual inputs, and also CSV to give another input on the KPI. From this ETL, it goes to the Go dashboard that Fauzi is going to show later. So from out of 300,000 Pi tags, we can actually converge the scope into 269 Pi tags only for the C-suites to focus on. So they don't need to worry much about all the other Pi tags on operational level because they are on the strategic level. So this is the only Pi tag that they need to worry about. So we inject also the KPI in this the dashboard so that they can actually know how is the performance throughout the time. So the first MVP for this Go dashboard is achieved within 1 month. So this product also has been going to continuous improvement in the product management and is continuously being improved. And then we release it every 6 months to ensure that continuous improvement. So with this implementation, we actually have observed some increase of our process cycle efficiency for 23%. So we did a Gemba walk before this dashboard being introduced, and now it's already introduced. How many is the process cycle efficiency improved? We also not forget about the adoption. So we did some survey on the customer effort score. So and then it achieved 6 out of 7, which is very good to show that actually the customer is actually like the product and wanted to use the product for the future. Okay, so I think enough of the talking. So we show you the picture. So I invite Fauzi again to show on the demo of the Go dashboard.
Hi, Ridwan.
Welcome.
Hi again. So basically, I will share with you and navigate you what we have in the Go dashboard. So as you can see in the screen, this is our page showing the map of Malaysia. It consists of all of our assets, inclusive of upstream and also the product delivery. So as an example, if we look to our assets, there is some indicator that the asset is not performing well. Then immediately you can compare what is the performance of our feed gas. If the feed gas is also having issue, means that our plant slowdown is mainly impacting but through the feed gas unavailability. But if the feed gas is good and our plant is not so good, there's something wrong with our plant. So our C-suite leadership can also drill down, navigate to more granular level. So this is example, one of our assets in Borneo. So over here, it will represent all the associate informations together for the assets, inclusive of some highlights provided by our operations team. So let's say if they want to know more on that particular assets, we provide the navigation to each respective application. So this is where the demarcation, what we have in Go Dashboard and all other operational applications. This is, we just want to showcase with you one of our lovely floating LNG in PETRONAS. And then this is another way for you to see all this information. It's a multifaceted view. You can see the information through the map that I showed just now, and also this is how it's been represented into a value chain. Yes, you can see how much the feed gas is coming in, how is the performance of our plant operations by products, and also the inventory level, and how it being flowed to our customers. To summary, as per shared by Ridwan just now, yes, we facing a challenges. It's about data, too many, it's not available, and then we come out with a few good solutions, building a product that people want to use, and then it's provide a good benefits. But the most important thing, if you see over here, through a good infrastructure of AVEVA Pi, it really helped and accelerate us to establish this product. So for that, another page. This is, if you want to know more on this, you can either scan myself and Ridwan. We can have chat later, either after this or tonight. This is the rest of the team members that worth to mention. Okay, enough said. I'm going to pass to Johari to share more other use cases in GTC. Over to you, Joe.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. All right. My name is Muhammad Johari bin Muhammad Akil, and I'm from a gas processing plant located in Kerteh, Terengganu, in Malaysia. Okay, in morning session, we heard about EOC, PETRONAS EOC, and then thank you to Fauzi and Ridwan explaining on the GNE Go Dashboard. And today, this is my turn to present more detail on how digital experience in how leverage on the digital to support the PETRONAS gas processing on technical center. All right. Okay. Before GTC in the picture, okay, basically. All the information all scattered. Okay, we under engineering services, okay, and also operation department have come out with the improper monitoring in order to support the plant operation. Based on the scattered information and analysis of plant data equipment, we foresee that the improper decision making that come out with the manual intervention on communication and intention on the plant issue. So our management is decide to come out with the team that how to encounter in order to support the plant to make sure all the engineering, all the plant department, all the operation department is get together and come out with there's one center that everything is under one roof. All right. So, all right. Collaboration effort was established between multidisciplinary teams and realizing the target. Basically, a GTC or Gas Processing Technical Center is a digital platform that was collaborate between all disciplines such as process, electrical, instrument, inspection, and mechanical to integrate all the tools under gas processing technical center. Okay, this collaboration was centralized and integrate all the information on plant operation and also equipment performance. Okay, and the GTC also equipped with advanced analysis for plant and equipment performance. And inside the GTC, we have equipped with anomalies notification and also all the deviation detection related to the potential plant and equipment issue. Okay, all the integration related to the department by department or section by section is integrated by work process. Okay, all right. Okay, this is the GTC or GPU Technical Center dashboard. It was integrated of advanced analytic tools covers across multidisciplines. Okay, from the GTC, we come out with the management dashboard, and then we have process compliancy, electrical dashboard, instrument dashboard, and also all the equipment healthiness and many others. Total dashboard, total tools that was received in this GTC basically is about 32 tools. So every day, engineers in gas processing open up all this dashboard by using PETRONAS web, and we monitor this GTC daily and support plant operation effectively. So daily monitoring was performed, and then this GTC will perform the anomaly detection and provide the email notification daily, and from there all the analysis by from engineer will perform by them and automatically support in terms of production and also maintenance as well on the optimization. Okay, this is the GTC architecture slide. Basically, the GTC perform from two segments, is engine and also the visualization. All right, from the engine we can see that we leverage on the Pi server and also support by Pi AF server. Two Pi AF server from that was used as a calculation development and also for the production. Okay, at the same time, on the engines part, they have integration with non-Pi, such as MVP, we call it as a measure, validate, and predictive tools, and reliability tools, and also we integrate with the icon simulation, and then PETRONAS machinery monitoring, which also we using AVEVA platform, and we covered by Shah. At the same time, all the plant optimization related, we also integrate with the Pi system. And then at the visualization stage, okay, we're using GTC web server, HTML, JavaScript to perform the visualization concept. All right. Okay, this is 7 solutions offered by GTC. Okay, basically GTC not supersede all the engineers function, all the operator and technician function. Basically, GTC is support in terms of how engineer perform the troubleshooting and also for optimization in maintaining the plant operation. So from there, we have, for example, we have early notification to operation and maintenance crew. At the same time, the function of GTC is we have online update on current plant status, and then also have the alert by alert analyzed by technical expert as well. Okay. Okay, in terms of benefit of the using the GTC, we have categorized based on tangible value creation and also intangible value creation. Based on journey of GTC development since 2019, and we completed the journey last year, December, we come out with the almost 300,000 deviation detected with the 385 genuine anomalies. From this number, we avoid about 150 trip prevention with cost of non-conformance avoidance to PETRONAS. I think this is a great effort that GTC bring to PETRONAS. At the same time, it come out with the intangible value creation, which is facilitate local authority approval on the regulatory requirement. At the same time, GTC also speed up the root cause failure analysis implementation. Okay. So from there, it's come out with the faster decision making as well. All right. So from the GTC implementation, I can see that this is the new way of working within gas processing, and I think this is the part of the key takeaway that I can see that is this is part of the collaboration effort between all the section in engineering unit, okay, by using good work process, and then role and function is integrate with work process and mindset change, how we utilize PIF in order to support plant operation, and lastly is the how reliability of the data to make sure we come out with the genuine anomalies to support the plant operation. Okay, I think that's all from me related to the GTC implementation. Anything related to how we integrate the GTC in the PI system, PIF platform, you can we can have more discussion about that. I think that's all from me, and then I will pass this presentation to my colleague, Cik Samsul, on the detail on the DigiPost.
Okay. Thank you, Cik Johari. Assalamualaikum and good afternoon to everyone. My name is Shamsul. I will proceed with the case number 3 entitled Enabling Smooth Operations by Flowchart Automation through PIF. Let me start my presentation by pointing out pain points that I think common to any organization, not only PETRONAS. So the first one is inconsistent judgment due to different experience and knowledge. Data and analysis are scattered, not in one place. Time consuming due to too many data to digest, and conventional monitoring method led to ineffective operation. So the solution of those pain points that I've just mentioned is that we adapt flowchart automation as enabler. The methodology of doing this flowchart automation is as shown in the slide, that we have 3 phases. Okay, the first one is flowchart and scenario workshop. So basically, we call everybody that involved in the development of the flowchart. For example, we call production planner, panel operators, and operation engineer. They sit together, okay, maybe in one room, and then brainstorm among themselves about the plant scenario and translate them into flowchart. Then, for example, let's say outcome from the workshop, they produce about 15 flowchart. We then break them into smaller groups, okay? For example, we group them into 6 flowchart, 4 flowchart, and 5 flowchart, every group. Then we enter in the for the next phase, which is called PIF configuration. In this phase, okay, The smaller group that I mentioned before will be executed individually by their group, and the team, same like the workshop team before, they will discuss, simulate, modify, and agree with the PyAF expression that that represent the flowchart that they develop. If there is some discrepancy or it cannot be the result from the flowchart cannot be met, the team weekly meeting will go back to the workshop team to redevelop the flowchart until they find the solution. And each of the group is executed independently. And then until each of the group finish, then we will move to the next phase, which is called the PyVision dashboard. This is where we integrate all the scenarios into a big flowchart. In PETRONAS Gas Berhad, we have two popular programs that we have developed called ProtaGrid, that is stand for propane and butane grid distribution, as well as DG POST, which means digital plant priority of supply. So in this PyVision dashboard development, we use PyVision software by using PyText dataset and PyAF path to develop this dashboard. Now, what are the benefits of this flowchart automation? Obviously, the first one is to accelerate informed decision. The operators now can just follow the advisory that is shown on the dashboard rather than calling the engineers. For example, if they have incident or in the morning, they do not need to call the engineers to answer them. So they can just see from the flowchart for the quick solution. Secondly, the data is presented in one stop center. It's transparent and reference to everybody, especially when we have a different side of gas processing. We can now look into one every unit can now look into one dashboard, and everybody understand each other. This also introduced new way of working. Previously, the decision making is done by manual calculation, but now it is all automated, and of course this introduced a new way of working. So what would I do differently is the key takeaways and lesson learned from this. So the first one is the flowchart development is most crucial process. So the successfulness of this program is that the flowchart has to comprise all the scenario in the plant. So if the team members didn't contribute much or very secretive, they cannot produce a complete flowchart. Therefore, the next step will be in trouble. Secondly, the reliability of the input or transmitters. So you know that in the plant, in the real plant, you cannot have a fully functional transmitter all the time. At some point, it will be bad, give you bad input. So how do you manage bad input? So in this case, you have to discuss with the subject matter expert on how to decide, for example, if the flow goes to zero or bad, how will they determine later on so that the flowchart is still going, can run. And the third lesson learned is the competency of the Pi engineer. We know that everybody has their own style of writing expression. So the competency is important here is because so that the code that the Pi engineer wrote is optimized so that it can minimize the affect the effect of PyF server loading. Okay, this slide just summarizes all that have been presented. So we have pain points, basically more to the manual work culture. Then the solution is we automate the flowchart, and then the benefit, of course, faster decision making. And that data is also presented in one-stop center, transparent and referenced by everybody. So that is me. So if you have more interest in flowchart automation, you can contact me. So now I pass to case number 4, Azmi and Swaizal.
All right. Thank you very much, Hamsal. And together with me, Azmi, our technical specialist. So, yeah, use case number 4, right? I'm really thankful for everybody for still being patient with us. I know it's multiple numbers from PETRONAS use case that will be presented today, and we are the second last, is it? Okay, for use case number 4, it's all about early failure predictions that we are utilizing on predictive analytics. One of the things that we have carried out earlier, maybe like back in 2 years back, we started this program, and there are reasons about it. So I'll go just direct on the summary of it. So these early predictions, in summary, the overall use cases that we're going to share with you guys is in regards of the challenges that we had initially, why we started it, and then we're looking into the solutions. What are the solutions that actually can bring us value and also the benefits towards this one? And as what we've been shown here in the slides that you can see right now, that is these particular solutions were built and created and being deployed to our implementation because there are 2 main reasons. One is in the result of the high value leakage that we experience in PETRONAS. That's the most reason. And the second one is about the people, whereas we required a certain visibility between our SMEs, between our operators, de-siloed a bit in regards of people at sites, because as for your information and also being explained by Ashman previously, we had multiple sites across. And this multiple site, we have engineers, but there are also a pool of subject matter experts at the central part. So we need to break that. We need to break the silo mentality towards the solutions. And these solutions, actually, we required some solutions that actually can bring us transparency, visibility, and early detection in allowing us to react to the issues faster and better. And on the benefits, it's about improving time to react, verifying by early predictions, and also, of course, the value leakage that we talk about, which is the key driver, which I will talk in a bit detail later on the next slide. So we'll just go to the, what you call that, the key driver. As you can see, being mentioned, PETRONAS, actually, we have like segmented business, starting from upstream, and then we have downstream, and also we have gas businesses. Even now, we have created a new clean energy solutions businesses, right? So, however, during the operational or the setup that we have within this particular business are quite the same, and it shows this particular equipment failure has occurred all across businesses, and this really actually what you call that a headache to us. Something needs to be done, medicine needs to be given, and these are the key drivers that required us to actually push ourselves to create a solution that can allow us to grab back all the leakages, the value losses for our productions and for our company. And then I would like to emphasize a bit, I think since day one here, and there are multiple speakers, even our today's industries, we're talking about the human side of things, how people trying to accept changes, how people trying, how do we put human into the ecosystems, right? So we are also trying to bring the new ways of working. And as you can see on the left-hand side, we see that traditionally, we have multiple tools that multiple parties are looking at. And these multiple parties, we're looking at into the same issues, but in a different perspective. Sometimes this impact in terms of what you call that, impacting the time to diagnostic, which is creating a longer time to react, right? And then I don't know whether you guys coming from the plants or not. Sometimes the blaming culture occurs. If you kind of, oh, this is operations problem, this is maintenance problems. So we try to break those things and try to bring it to the new way of working by actually putting all these people, the subject matter expert, the personnel, into the same table, looking at the same visualizations, attacking the same issues over and over again, as a team, better collaboration among them. So in doing that, we know we have losses in value. We know we need to bring those people together. And somehow, time is not really our friend at that particular time. We need to deploy and implement as soon as possible. So that's why we utilize the agile methodology, where at first, we establish a pod. This pod consists of multiple disciplines. We have instrumentation people. We have, of course, the rotating equipment people. We have the process people, the PI system people. We also embedded our AVEVA partners into the system. We get them together. We clear off our hats and being one in the same pod to ensure we deliver it with focus. Initial planning for one equipment in deployment is actually take us 3 months. But by sitting together, undergoes this agile methodology, actually we cut off this 3 months period of initial planning into 3 weeks, which is one sprint for one train at that particular moment. But now, due to the iterations that we made through agile, we managed to get more than one train or more than one equipment into implementations and deployments. Then we can achieve this by always having a better focus in the pod and also keep on iterating and enhance. And now, after the deployment, we have scaled it up towards across multiple businesses. I think we have like kind of beyond hundreds trains that we have already implemented this. And we gain that value in the what you call that, in the very short period of time, utilizing the solutions that we have created together with AVEVA and also PI system within less than 3 months for the initial POC. And this allowed us to scale up to other sites. And if you can see on the right-hand side, the simple diagram, we get this data from the equipment at sites, going to PI, Microsoft historian and data archive, and then it been channeled and modeled through AVEVA modeling. And then we have certain visualizations in our remote. You can see that from everywhere. So we have cut off the initial items that I said that we have SMEs at center, but the issues is on other regions. Then we have managed to complete that and also deliver that to our customer. So now, Azmi will be talking about more on the technicalities, features that we like to highlight. Not everything. I'm sure we don't have time for everything, but Azmi will take you through some of the features that we have established through this platform. Thank you.
Okay, thank you, Haizal. Let me first introduce myself. My name is Azmi Malasin. You can call me Azmi. Currently, I'm the principal engineer for rotating equipment in PETRONAS. So, okay. Let me talk about the technical parts on our journey towards this detection of equipment anomaly. So, we have finally selected AVEVA product called Prism for us to basically detect any equipment anomaly at early stage. So, what does Prism function provide to us? Basically, they use the algorithm to calculate and predict the equipment operating parameters and compare it with the actual operating parameters of the equipment. the moment there is a deviation between the predicted value and also the original actual values reach the predefined threshold, then the anomaly will be triggered to the users. So by having these features, it helps us to have early warning of any potential equipment anomaly. So in order for us to complement these features, we at PETRONAS have developed and also enhanced our FMEA to include not only on the regular failure mechanism, but also we add in the mitigation action that is necessary to address the anomaly. So by having this enhanced FMEA, we embed that into the AVEVA Prism. And with these features, it will provide automated fault diagnostic, which will help the user to easily troubleshoot and identify what is the anomaly that happened in the equipment. So on the screen, on the left is our FMEA template that we prepare in Excel. And then on the bottom, whereby we translate this enhanced FMEA into the AVEVA Prism through the AVEVA client. So this FMEA, we consider it as a live document, whereby we could always revisit and improve as and when required. Okay, just now I mentioned about the prediction and also on the prescriptive function of the AVEVA Prism software. So we also complement these two functions by also applying the time to failure or rule, remaining useful life of estimate, whereby it functions basically to estimate and provide an insight on when is the timeline for certain parameters of the equipment to reach and hit the predefined alarm or the tripping set point. Okay, just to give you one real case example at one of our petrochemical plant, whereby the syngas compressor had experienced high vibration on both the outboard and inboard side. So over time, the vibration keep on increasing, and it has triggered the maintenance team to conduct the RCFA. Based on the RCFA, they concluded that this equipment, this compressor required to be shut down immediately for them to address the issues. However, since this plant is very critical and the production demand was very high, somehow the management decided not to give permission to shut down this machine. And hence, where we apply this TTF function to basically estimate when would be the vibration reach the alarm and also tripping set point. Based on the estimation result that we obtained, we somehow managed to and confidently continue to operate the compressor until the next few months. So based on this decision, basically we managed to avoid unplanned shutdown to the petchem plant, which could result in a loss of production. Okay, since we established and applied this solution back in 2019, we have scaled up this application across PETRONAS group-wide. To date, we have deployed up to 125 equipment trains, which equivalent to around 380 equipments and more than 500 models. And we currently focusing more on the critical machinery, which is the turbo machineries. And on top of that, we have also deployed our solution to our offshore and also downstream facilities. Since the adoption of this solution, we have generated value creation, either tangible or intangible. So just to name a few, we have obtained an increase in equipment uptime as a result of avoiding the unplanned shutdown. And also, we created a better collaboration between the multi-discipline, which is the operation team and the maintenance team. And then next, in terms of the maintenance cost, we managed to reduce significantly as a result of the proper planning and also fit-for-purpose rectification activity. And also in terms of the asset utilization, asset reliability, and also the equipment overall effectiveness, we also managed to obtain increase in performance. And of course, last but not least, when we talk about this value creation, we must be very interested in terms of the monetary value. So to date, we have achieved value creation in the form of cost avoidance to the tune of millions of dollars. So by having this application, it's really provide a good return of investment to our company. So in summary, by having this solution, implementing in our facilities, it helps us to manage and also to operate our equipment effectively, which is translating into significant value creation. So I hope this initiative will be further scaled up. And also this year alone, we have received encouraging requests from our customer to deploy this solution. So with our partnership with AVEVA, we hope our collaboration will bring greater height to PETRONAS in terms of the equipment reliability. So on the screen is my contact and my colleague contact. Should you require any information, you could always reach us later. So now I pass the next stage to my colleague, Ashman. Thank you very much for your attention.
All right. For the last use case, number 5, I'll be sharing more on the enhanced insight by leveraging first principle process simulation. So the idea is we can achieve operational excellence by using and leveraging the first principle process simulation. The challenge that we have, the pain point that we have right now in PETRONAS is to achieve high accuracy of equipment performance calculation, such as efficiency, power, and duty. The generic calculation usually provide only estimation which is based on rule of thumb or historical experience is not very accurate. And lastly, it involves a tedious and labor-intensive manual key-in for the engineer to produce equipment performance report. With that challenge, we've come up with a solution where we integrate with our in-house high accuracy first principle simulation software, where we calculate that data to provide a better insight of our equipment performance. We also leverage on the PyAF analysis to perform calculation of certain parameters or certain instrument sensors that is not available at plant. For example, we don't have any text in the plant. Next, we automate the solution to run online to make sure we get the near real-time calculated data via PyData link. After performing and integrating that calculation, we stock back that data into PyText so that it can be consumed to the other application. For example, the AVEVA predictive analytics. And we also, in our solution, we leverage on for the near real-time visualization, where we leverage on Power BI and also PyBA integrator. The result of having this solution, it helps to give more accurate calculation of equipment performance. And we were able to use the first principle to calculate the efficiency of the equipment. And lastly, remove the manual intervention from plant engineer to provide that calculation. These are the example on the floor how we of the solution that we've developed. First, at the field equipment of the existing data, temperature, pressure, and flow, we historize it in our PyData archive and contextualization in PyAF. and perform any calculation, simple calculation that, for example, where the sensors are not available at a field or a plant. Then we take that data and use our in-house icon symmetry to calculate the efficiency of the equipment by using first principle model. And also we've developed a custom script where we help to filter value for that calculation. Typically, for any calculation, anyone would have this issue. If the input or parameters are having a bad data, you have basically main three options, whether you want to use your last good value, or you use your static replacement value, or to skip all the evaluation. In here, we use fixed value to help to further calculate if there is any bad data that is used for that calculation. And lastly, after that, after performing that calculation, the result is being stored back in PyData archive. And after it's being saved as PyText, then it can be used for any other applications. In our one of the use case, we send back to the AVEVA Predictive Analytics to help further correlate and improve our model. And also, later on, I'll be sharing on how we visualize it also in Power BI by using the PyBA integrator. So these are some of the examples of the compressor performance plot that we're using Power BI dashboard. This made available by using the PyBA integrator, which helps to come up with the plots of the compressor so that it will be easy for the engineer to monitor their compressor at their sites. What are the lessons learned that we've learned? The key important things that we've learned throughout this project is, first is to understand user requirement, start small, and also closely collaborate with other reps. I believe in many of our presentation just now, these are the recipe to make sure that the solution that we've developed are being adopted by the user, and it's being used for their daily usage. So understand user requirement, start small, and collaborate between the collaboration between different experts, engineering, IT, or your data science team will actually help to create a competitive and reduce the cost of your deployment, application deployment. Next, for the future plan, we are planning to replicate the same methodology for all other equipment that can be modeled via first principle process simulation, such as gas turbine, heat residual, SG, and also distillation column. Yep. So this actually wraps up the last use case that I have. So by using AVEVA Pi and also AVEVA Predictive Analytics, it is vendor agnostic. As you can see, we've integrated not only with Pi application, but it enables to integrate with any other tools, which actually helps to sit in whichever tools that you have existing in your plant or site as well. Okay. Lastly, for any question, I'll be happy to answer any question that you have. And a special thanks to the team to develop on this integration, Hidayah, Azin, and also Zafira. Okay. All right.
Oh. I don't know about you, but that was impressive. A lot of case studies really illustrated the power of data and information and how they're transforming themselves. So anyway, we have time for one, maybe two questions. Do we have any questions in the audience? If not, I'm sure that they will be available at the function tonight and tomorrow, but for sure tonight. But again, I would like to say a big thank you to the PETRONAS team. Just amazing presentation. Slideware is fabulous. And so just really, some of the benefits were just like really, really impressive. So thank you very much.
Thank you so much, Greg.
Thank you. Thank you.
Okay.